Okay, hi, I'm Mr. Kwang. Today we'll start on lecture 3A, Functional Abstraction. Alright, so today we're going to learn about how we will use functions. How do we define functions and all? Okay, so understand the idea of a function in programming. Alright, what exactly is a function? Before we talk about what a function does, let's just quickly define the form of a function first. A function always, when you start to define a function, you always start off with define, def, then followed by the name of the function. This name can be set by you, it can be arbitrary, but usually we choose a meaningful name. Okay, then we open the bracket and then we insert the parameters that we use for the function. So this is also known as the arguments, the values that we input into the function so that the function can run. Okay, sometimes there's no arguments, but let's not talk about this now. Then after that, it's always followed by a close bracket and a colon at the end. And once you press enter, you start to enter the body of the function. So this is what you want the function to do, what kind of evaluation you want it to be done, what kind of values you want to be returned. So, but to make it clearer, let's look at how an actual function looks like. Okay, so for example, we have a function called square. Okay, so this is the defined term, and then this is the name of the function. All right, and this function square takes in a single argument of x. Okay, there could be more than one argument given. All right, the next thing to note that this is the body of the function. Note that there's a 4-space indentation from the first line. Okay, so once you press enter after the colon, it will in Jupyter it will automatically give you 4 spacing. All right, and let's say if you press enter, it doesn't give you 4 spacing, right? The most common error is that you probably have missed out on the colon. Okay. All right, so this is how a typical function will look like. Right, here we define a new variable within the function result, and then we let it be equals to x times x, and then after that we'll return the result. All right. Okay, so this, like what I said, this expression. Yep, sometimes the result may not include the parameter as well, but this is usually quite rare. Like, but when we return, as in we don't usually return the parameter itself. We will return something else. But again, this is flexible and depends on your needs. Right. So let's look at this function square 2. Okay, so we take square, then we put in the argument of 2, and we run this. We get 4 because basically this function takes the argument and just squares the value and return the squared value to you. Okay, then you have square 2 plus 5. So 2 plus 5, you know, is 7. 7 square will give you 49. And next, how about this square 3? Okay, so basically how this works is that this first call of the function will act on this 3. Then after that, the second call of the function will act on the result of square 3. So square 3 will give you 9. Square 9 will give you 81. Okay. Alright, so essentially, right, when you use a function, you don't really need to care. When you are using the function, you don't really need to care what's inside the function. You can just use it directly. Okay, that's the most important thing to remember about functional abstraction. Alright, so you don't need to know how it does the job. You just need to know what it does, right? Okay, so for example, I have a function called square x again. Okay, then in this result here, this result, I can sub in a suitable expression that will still give me the right outcome. Okay, remember the whole point of a function is that this square function will just return me the square of the value. So there are many ways of getting to that squared value. Okay, of course, these are some of the possible ways. There's just x times x. There is this double asterisk, which remember is basically means power, so x power 2. Of course, if you want to be very extra, you want to go a very complicated route, you also can do that as well. This will still give you x squared. Okay, so function, like I said, is a black box. And in this case here, we give you a function that takes in 2 variables. Okay, if you look at this 2 variables, right, x and y, when different values are assigned, you get different outputs. And I think from the first 3 rows, you can tell what exactly the function is doing. Okay, you can make a good guess, but I think it's quite clear that it's basically returning the sum of 1 and 2, x and y together. So there's 1 plus 2 give you 3, 2 plus 3 give you 5, 3 plus 4 give you 7, 5 plus 6 should give you 11. Okay, again, this is another function. You will learn to write this very, very soon. Okay, so this function basically checks for whether a year is a leap year or not. Okay, so I input the year, it goes through this function, then it return me a true or false value. Okay, so if you look at the year that's used as an input, this is 2000, and this will give me true. 2100 give me false. 2104 give me true. 2018 should give us false if I remember correctly. You can check. Okay, so sometimes if we want to get the value of the function, right, if we want to get the output, right, we need to use a return. All right, if there's no return, right, then it is treated as a non-output. Okay, so it depends on what you want again. All right, so let's look at this case here. We have learned to use print statements earlier in the class. All right, so these two functions look kind of similar. There's a square x result equals to x times x, but the difference in the lines is one is printing result and one is returning the result. All right, so if you just run this, right, you should get the same output on Jupyter, but there's going to be some differences that will come up very, very soon. Okay, so if you can try this on the next page. All right, so if you do it this way, right, if you use a print result, okay, actually what Python assumes is that when there's no return in the function, you will assume that you are returning none. All right, so whatever results you're printing, that's fine. But then if you don't have a clear return statement there, right, Python will just assume that you do not want to keep the value of the result. Okay, you do not want to keep the outputs of the function at all. Right, so let's go on. Let's look at this. Okay, when we put in the parameter in the function, right, if we use a print statement, we are basically getting a display. Okay, we are getting something printed on the screen. And once you print it out, right, yes, it's there, but then you cannot reuse it anymore. You cannot say, for example, you print the result of square x, right? Yeah, let's say you put square 2, you'll get printed 4, but you cannot make use of that 4 directly. All right, but if you return, let's say you return the result, right, you can assign this return result, right, into, let's say, another variable, and then you can use that value. Okay, and also there's something about this. If you don't assign the result to a variable, or you don't use it immediately, Python will forget the result after the function returns. So for example, in the first cell here, right, I'm running square x, then I get return result, then I run square 2, I'll get 4. Okay, by the next cell, I try to print the result thinking that, oh, I'm just using the result from the previous one, right? It doesn't work. Your result is not defined anymore. Okay, because once you use the function, you use the function on the arguments. If you don't use the result straight away, or you don't store it into a new variable, the result is not remembered. It's cleared off. Okay, we will stop here. Then we will continue the next session.